Okay, so on 31, girls, I'm just going to go over 31 first because we didn't get to it that type yesterday. So on 31, they give you the first three terms of the sequence, thank you. And they tell you it's an arithmetic sequence. So by you can't really see right away what the common difference is because you're dealing with x's. But you do know that it's arithmetic. So whatever you're adding as your difference to get from the first term to the second term has to be equal to whatever you're adding to get from the second to the third. So between the first and second, let me go with Cameron. What am I adding on to x plus 4 to get to 2x plus 5? Just an x. I'm adding on an x to get to 2x and an extra 1 to get from 4 to 5. Does everybody follow that? So this common difference is x plus 1. That's what I'm adding on. If you look between terms 2 and 3, Andy, what am I adding on? To get from 2x to 4x first. 2x. Right, and to get from 5 to 3, you're actually adding on a negative 2. So if it's an arithmetic sequence, though, those should have been the same, right? And that's exactly where this is going to come from. Set them equal to each other. They should be the same. So figure out what the x value is that will make them the same. So if I just solve this equation, subtract this x over to get rid of that, add this 2 over to get rid of that, I end up with 3 equals x. And then some concrete proof would be good. So your first term, if x is 3, 3 plus 4 is 7. Your second term, if x is 3, would be 6 plus 5, 11. And your third term, if x is 3, would be 12 plus 3, 15. Does that appear to be an arithmetic sequence with a common difference? What are you adding on? And then 4 again. So this is the correct x value. So we did that, and then it just wants the fourth term. So 7, 11, 15, and 19. Okay? The other thing that I know came up on the homework was in 11 through 14. Given the first term and the common difference, find the first 5 terms, which that was not the issue. We just kept adding 10, adding 10, adding 10. To get the first 5 terms. It was the finding of the explicit formula. So the explicit formula, and in order to write it, comes from the formula that you will be given on your reference sheet. If you're writing a formula for any nth term, you just kind of plug in what you know, which is the first term and d. So if I plug in the first term of 28, and I plug in a d of 10, that's an explicit formula. It's just not simplified yet. So on the answer key, the 10 had been distributed, so it's 28 plus 10n minus 10, and like terms had been combined. So the 28 minus 10 makes 18, so it was 10n plus 18. And that is the simplified version of an explicit formula. So now, if someone wanted the 37th term, you wouldn't need to add 10 36 times to get there. You could just plug in 37 to your explicit formula. Do we follow? And do we see the resemblance to mx plus b form? Yes? Okay. In mx plus b, what does the m stand for? If this was y equals mx plus b, what is the m? The slope. So kind of making the connection, like Nathan pointed out yesterday, that your common difference is your slope. What does the 18 stand for? In mx plus b, it is the y-intercept. In this, does anyone know where that 18 would come from? Before I get to Nathan, what do you know about y-intercepts? That is when what equals what? It's on your flashcard. If it said x equals 0, good, Jordan. So if your y-intercept is when x equals 0, Nathan, what were you going to say? Right. It's like going back to your 0th term, which doesn't really make any sense because, right, we would always say the first term. What's the 0th term in a sequence doesn't really make logical sense. But if you did think backwards, rather than adding 10 to go forwards, you would subtract 10 to go backwards, and a sub 0 would be 18. And that jives with what is the y-intercept. So just a connection to be made there. Okay, any other questions on this? Cameron. Yeah, some of these didn't copy great. I think it was a 4. Raise your hand if you used that as an a sub 4. Did it match the answer key? Okay. So, yeah. They're kind of blurry in the sense that actually the further away you are, like looking up at the board right now, it looks like a 4 to me. But if I look at my paper and I get really close, it actually distorts it more. I don't know why that happened. But yeah, I'm sorry about some of these. Any other questions, Lydia? Okay. I can go over one of those. Anything else? I'm just going to go over one of them, though. Okay. It wasn't, Bo, is it -3? Well, right, and they're asking you for y. Yeah. So the y value is -3. It wasn't there. Okay. Sorry. Oh. But, so that one was on there? Oh, I don't know how I screwed that up. Sorry. So -3. Andrew? Okay, that's what I'm going to go over. Okay, pass them forward. So on this one, we are not given the first term. And this is the classic type of example where I know the Regents gives you this a sub 1 version, but I want you to know that that 1 limits you to just having the first term, which you don't have here, which is why I rewrite it and change my 1 to case, so I can use an nth term and another term. It's not necessarily the first term. So I always like to make my nth term the later of the two. So here I have an 18th term is that, and the 38th term is that. So I would let this be my nth term. This is a sub n, and this tells me that n is 38. So n stands for the number of terms that I'm given, so 38, and a sub n is whatever that actual term is. And then over here, this will be my kth term, and this tells me that k is just 18. Do you follow that? Okay? Yes. All right, well, we're going to do it. So, and the slope formula can be used to find your d's. If you want to go that way, you are absolutely. I'm going to try to use these formulas as much as possible because I can only, predict so many different variations of where they might give you these two, but not this one, and somehow, change that by where they want you to use the formula. That is the real purpose. So let's maybe once they do it, you'll see. So a sub n is my nth term, which is 7362. Equals my a sub k is my kth term, which is 3362. Plus n minus k is my 38 minus my 18. And then my common difference is what I'm looking for. So if I subtract this 3362 over, I get 4,000 equals divide both sides by 20, and D is 200. Okay? Okay. Okay. So then we're actually writing recursive formula. Writing recursive formulas is typically easier than writing explicit, because you just say, I'm taking the term before, a sub n minus 1, and doing what to it. If it's a common difference, you're just adding on 200 to the previous term. Now, for the camp of people that really insist that they want the first term for the recursive formula, we then now are going to go back and kind of do this process a second time, which is a common thing in this chapter, like this maze of using the right equation. Now that we're looking for the first term, we can use this one. We use this to find D. But now that we know D, we can use this one to find a sub 1. So if I go back, and I'll switch colors up here, I can still use for a sub n, I can still use 7362. Equal. I'm not using anything for a sub 1 because I'm on plus for that. And then n is still 38 minus 1. And now d, I'm going to 200. So if I just kind of crunch these numbers on the right, that's 37 times 200 over 7,400. And then subtract 7,400 from both sides, I'm going to get negative 38. And so that will finish off my recursive formula. Okay? And we had to grind through the equations twice, which is very common, and I get it, we'll need to use it too. But maybe if you highlight what you know, kind of like I did up here, from the start, it will clarify a little bit for you. Okay? So, today we're moving on to geometric, which is going to be a lot of the same processes, using equations twice, giving different pieces of information. It's just, it's a different formula. That's a different formula you're going to have to go through. This is the geometric sequence formula. This is the arithmetic. Okay? They both use a sub n. They both use a sub 1. They both use n for the number of terms they're on. The main difference is that this one uses d and this one uses r. And we already know that d stands for the common difference. Any idea what r might stand for? Rate, kind of, sort of. It's called the common ratio, which ratio comes from rate, so we're far off. The common ratio is the common multiplier that gets you from one term to the next, right? So if I see 4, 8, 16, 32, my multiplier is times 2 times 2 times 2. So r would be 2. Okay? The reason they call it a ratio is because really when it's not as obvious as this is pretty obvious, right? Times 2 times 2. In order to figure it out, you literally set up that ratio of this divided by this, which I think maybe you came up with yesterday. You said take this and divide it by that. Right? To get the common ratio, you can take any term and divide it by the term before. So the ratio can always be figured out by taking some nth term and dividing it by the term before. And that'll, be more necessary in certain instances. Here, because this is so obvious, times 2 times 2 times 2, you don't really need to do 8 divided by 4 to figure out the 2. But on some, when the multiplier is less obvious, you do have to do that. Make sense? Absolutely. The perfect analogy. D is to arithmetic sequences, as R is to geometric sequences. Okay? And they come with a slightly different formula, but the way in which we use them and the kind of plugging in and finding the missing items is exactly the same. Okay? So if I jump to your notes, probably after me talking about what I just talked about, can we fill in some of the top already? Terms of a geometric sequence have a common ratio. Determine the next three terms of this sequence. Connor, what do you think the next term would be? 3/16, then 3 over 32, and then 3 over. So the pattern that we all can probably identify is that the denominator is doubling. But that is not going to help you for the common ratio. What is the multiplier getting us from one term to another? What do you think, John? What are we multiplying by to get from here to here, and then again from here to here, and then again from here to here? A half. Yes. Now, that's great, John, that you could see that. If you can't see that, just remember, you can find your common ratio by taking any term and dividing it by the term before. So in this particular problem, again, you can take any two consecutive ones. Let's say we'll just do the first two. You can take 3 over 2 and divide it by the previous term, which is 3. And then it's a little bit tricky here because they're fractions. Change the division and multiplication and flip 3 to 1 over 3. And your 3's cancel, and you get 1/2. So the common ratio is 1/2. Obviously, a lot of you figured that out without doing that division thing. But if I bring you back really quickly here to not yesterday's homework, but the day before that, when this was the problem, what's the common ratio that gets you from 100 to 80? And then from 80 to 64, and then from 64 to 51.2. In order to figure out that common ratio, you divide 80 by 100, and you get 8/10 or 0.8. And that's the multiplier, times 0.8, times 0.8, times 0.8. And it gets uglier the further you get because your numbers turn into more and more decimals. Okay? So some are obvious, some are not, and I just want you to be confident with the ones that aren't as obvious how to calculate it. Okay. So, given the first term and the common ratio, find the next 4 terms. So, because they gave us the first term, we're just going to multiply by -2. We get -6. Multiply that by -2. We get 12. Multiply that by -2. We get -24. Multiply that by -2, and we get 48. When you multiply by a negative, what do you notice about every other term? Negative, positive, yep. B is a little bit tricky because we're multiplying by a fraction, and I know we don't love to do that. But what is -2 times 2/3? How many thirds? -4/3, very good. And that can't be reduced, so we're good with that. A sub 3, we got to multiply this by 2/3. So -4/3 times 2/3. No, it's not thirds anymore. The only reason it stayed thirds was because a whole number has a denominator of 1. -8/9, very good. And then A sub 4, when I multiply this by 2/3, is -16 over 27, and lastly, multiply by 2/3, that'll become -32 up top and 81 on the bottom. Okay, now again, we have a recursive, which is pretty straightforward. We just take the previous term and multiply by r. With arithmetic, we add a d to the previous term. Now we're just multiplying by r. Explicit formula I have here, and it's the same one I had written on the board, but again, it limits you to the first term. So there is a different version of this. We can change our 1's to k's, because although it's wonderful when we're given the first term, Lots of times that's not the situation. You're given the 7th term and the 11th term. So I just changed my 1's to k's, and it makes it 10 times more useful. Okay? So, for example, this next one gives us the 10th term and the common ratio and asks us for the first 5 terms. So we need to find the first term, so we can use this one. And again, maybe this will help. This is going to be a sub n, and that means n equals what? 10. Our 10th term is 8. So if I plug into that first formula, a sub n is 8. A sub 1 is what I'm searching for. The common ratio is 2. And then in the exponent, 10 minus 1. So this gets simplified to 2 to the 9th power, which I'm going to leave as 2 to the 9th, and you'll see why in a second. Because I have to divide this over, yes? Let's pretend you don't have a calculator. How do I do 8 divided by 2 to the 9th if I don't have a calculator? Nate? Right, rewrite 8. 8 is the same thing as 2 to the 3rd power over 2 to the 9th. And then you can follow your exponent rules, which is to subtract those. So that would be 2 to the negative 6th. Thank you. Which is 1 over 2 to the positive 6th. That's simplest exact form. Yes. Yes. Wait, where is Haley? Oh yeah, you are. I knew I saw you. So if you wanted the exact answer for this, 1 over 2 to the 6th is kind of a crazy decimal, which is why we might choose to leave it like that. Okay? So that's your first term. I'm just going to leave it like that. Then my next term, I just need to multiply that by 2. What's going to be the... What's going to happen if I multiply this by 2? Technically 2 to the 1st power. Isn't that just going to cancel with one of these and make that turn into a 5? Right? 1 over 2 to the 6th times 2, that's technically over 1, and that's technically to the 1st power. So this 2 will cancel with one of those 6, making it 1 over 2 to the 5th. And that's going to happen over and over again. So the next one will be 1 over 2 to the 4th. The next one will be 1 over 2 to the 3rd. And the last one will be 1 over 2 squared, which is 1/4. Okay? The next exercise wants us to find the 10th term. It's given us the 1st and the 5th. So we are lucky they've given us the 1st term, so we can focus on this formula. But let's identify. Obviously, the a sub 1 takes care of itself. 1.5 is our a sub n, and what's our value of n? 5. We're dealing with the 5th term, and that 5th term is 1.5. So we're going to find r first, as instructed. So a sub n is 1.5. A sub 1 is 24. R is what we're looking for, to the 5 minus 1 power. So what do we have to do first to start getting r all by itself? Not subtract, because it's attached with a multiplication. Divide, yes. And that's not going to be a great number. 0.0625. But then how do we get r all by itself? How do you get rid of a 4th power? 4th root, or raise it to the reciprocal, right? Because when you raise it to the reciprocal, the 1/4 power on both sides, that's the power to power rule. And anytime you multiply a number by its reciprocal, you get 1. So it's r to the 1st power, which is just r. And 0.0625 to the 1/4 power, or the 4th root of it, is 0.5. So once you have r, and we did this last night, we can write now an explicit formula. Okay, so if I go back to my explicit formula writing, a sub n will equal my first term, which is always going to be 24, times my rate, which is always going to be 0.5, to the n minus 1 power. You may want to put your rate in parentheses just to resist the temptation of multiplying the 24 by the 0.5. You cannot do that because the 0.5 has its own unique exponent. But now that's the explicit formula. If I want to find the 10th term or the 99th term, I just plug those numbers in. So if I want to find the 10th term, n is 10. So a sub 10, or the 10th term, equals 24 times 0.5 to the 10 minus 1. And you just type that into your calculator. 24 times 0.5 to the 9th power. 10 minus 1 is 9, obviously. You can do that in your head. And we get 0.046875. If these are multiple choices and the answer is in a fraction, you can just do your math and fraction button, and you'll get 3/64. Okay? Do you see how the mechanics are very similar? It's just now instead of solving linears, we're solving exponential type equations. Okay, take a look at the back. We're given a 3rd term and an 8th term. We still have 10 minutes. Okay. 3rd term and an 8th term. Find r and find a sub 1. So if I use my k version of this formula, a sub n equals a sub k times r to the n minus k. Which one do I prefer to make your nth term? The larger one, the a sub 8, the one that's further along in your sequence. So this is my a sub n, and therefore my n is 8. This is my kth term, and therefore k is 3. So I'm first going to use those 4 pieces of information and find what's missing. So a sub n is negative 16. A sub k is 1/2. R is what I'm looking for. And then n minus k is 8 minus 3. So to solve for r, what's the first thing I do, Kaylee M? Divide by 1/2, which is the same thing as multiplying by the reciprocal of 2. So that's negative 32 equals r to the 5th power. Now what do I do to both sides? Both? Not multiply by the reciprocal, raise it to the reciprocal. I have a feeling you would have written that, but you said it wrong. So raise it to the 1/5. And r equals, does anybody know the 5th root of negative 32? No, we're taking the 5th root. The only times i's come up is if you're taking an even root, like a square root or the 4th root, because something does multiply by itself 5 times to give you negative 32. Negative 2, right. So you can have negatives when it comes to odd roots. Does that make sense, Nate? Both Nates, I guess. All right, so now here's that kind of maze again. Now that we know r and we want to go backwards and find a sub 1, we can go back and use the formula that actually did have those 1s from the start. Still going to use the same. A sub n is negative 16. Now I'm looking for a sub 1, so I can leave that alone. Times my rate is negative 2. That definitely needs to be in parentheses. Anytime your base is a negative number, definitely needs parentheses. And then my n was 8 minus 1. So on my calculator, I'm just going to do negative 2 to the 7th power. And I get negative 128. And divide both sides by negative 128. And my first term is a decimal 0.125. But you're more likely going to see that as a fraction. So math, fraction, 1/8. First term is 1/8. Okay, so the next exercise gives us a formula. What kind of formula is this? Explicit or recursive? Recursive, because you see that subscript of n minus 1. And I know it's arithmetic or geometric. Well, we're doing geometric today, so you'd be best to guess geometric. But why? Why do I know that's geometric? Nate? Yeah. It's because you're multiplying. If that was arithmetic, it would say 4 plus the previous term, right? So they're kind of telling you that you're always taking the previous term and multiplying by 4, multiplying by 4, multiplying by 4. So in essence, by giving you that formula, they're telling you your common ratio is 4. And then we can just write an explicit formula, because that's what this is. A sub n equals our first term, which they told us is 8, times our common ratio that they kind of gave us. We had to extract it, but it's 4 to the n minus 1 power. And that's an explicit formula. So now if we want the 100th term, we don't need the 99th to get it. We don't need the 98th to get that. We can just explicitly jump right to the 99th. Okay? The recursive is a dead giveaway when they have subscripts. Okay? I want to jump to the second example in this next section, which is asking us to write the recursive formula. So essentially, to write a recursive formula, I say the nth term means I'm taking the previous term, a sub n minus 1, and what am I doing to it? Not adding, multiplying, because they say r equals 2. If it was d equals 2, then you're adding 2, because that's the common difference. So we're multiplying by 2. I'm going to put that 2 out in front. The other piece that you need to give with a recursive formula is a term, and let's pretend like they asked specifically for the first term. If that's the case, we would just need to take this information and our formula and find the first term, which I'm not going to do because I really want to get to that last one. But we would just plug everything in and find the first term, and then once we have it, put it there, and there's our formula. That's our recursive formula. I want to get to this last one because it was kind of similar to that X one last night. The first 3 terms of a geometric sequence are given. Okay? Find X. So they tell you it's geometric, so you know it's the same multiplier every time. What are we multiplying by to get from 5x to 10x squared? 2x. What are we multiplying by to get from 10x squared to 100x squared? 10. Well, those are supposed to be the same. Yes? You're supposed to be multiplying by the same thing every time. Well, they can still be the same as long as x is 5. So x equals 5. And then you can kind of go back through and say, okay, so now that I know what x is, my first term was 25. My second term was 250. And my third term was 2,500. Just by plugging in my x's. So you can see it now. Times 10, pretty obvious. Times 10, pretty obvious. What's my next term going to be? What do you do when you multiply a number by 10? Add a 0. Okay, so the same idea of that arithmetic one that we did last night, there's a geometric version. Okay? So your homework is coming out. You're going to have a short quiz on these sequences tomorrow. These are going to be given to you. Okay? Just know how to use them. Arithmetic, geometric, very similar usages from yesterday's day, just different formulas. Are we good with that? 12, 14, 18, and 20, just to cut it down a little bit. Last year I flipped the chapter with this book, so we had all class to work on it, so they're a little bit longer, if you noticed that. And then on the back side, you can feel free to cross out 24 and 26. That'll just cut it down for you. And it won't be so much busy work.